In today's class, we are just going to learn about linear growth in action. That means what is linear growth? Okay, linear growth, which means that it grows by the same amount in each time step. For example, the cost of a journey is given by the linear function. Okay, C of D, which is nothing but cost of the journey for the distance. It's given as 100 plus 60D. C denotes total cost. D is distance travel in kilometer. Okay, this is the linear function is given. Okay, so distance travel. Okay, if it's a 0 kilometer, that means in the beginning, the cost is 100 rupees. Okay, 100 rupees is a fixed charge, we can say. So for each extra 1 kilometer, we have to pay 60 rupees extra. So that is a tabular column is given. Okay, so distance travel, if you are traveling extra 1 kilometer, right, 100 plus 60 into 1, we'll be getting 160. If you are traveling for 2 kilometer extra 2 kilometers, so D it will become 2. 60 into 2, that is 120. 120 plus 100 is, okay, 220. Next 3 kilometer, 4 kilometer, 5 kilometer, 6 kilometer. Okay, so now here, right, so the distance, if it's increased, the cost also, okay, keep on increasing. So in this example, as the value D increased by 1 kilometer, the value of cost function C increased by the fixed amount, that is 60 rupees is increasing. So this is an best example for linear growth. Okay, linear growth, which means that it grows by the same amount in each time step. Okay, here the same amount is 60 rupees. 60 rupees is keep on increasing. So these type of situations comes under linear growth. Linear decay. Okay, linear decay means that it decreased by the same amount in each time step. Linear decay means that it decreased by the same amount in each time step. For example, okay, the height of the water in a cylindrical tank is 3 meter at the start of summer. The height is h meter at the end of t month is given by the linear function h of t. H denotes height, okay, t denotes month. Okay, 3 minus 0.5 t. Okay, in the beginning, 3 meter height, okay, it's decrease, okay, every month by 0.5 height, okay, 0.5. So this is the linear function for the given condition. Okay, month, okay, initially if it's 0 means, so height is 3. Okay, after 1 month, okay, the height is getting decreased by 0.5 meter. Okay, that means 3 minus 0.5 is 2.5. If it's second month, after second month, it comes to 2 meter. Third month, 1.5 meter. In fourth month, 1 meter. Okay, height decrease by 0.5 meter every month. Okay, in the beginning, 3 meter height. So every month is decreasing by 0.5 meter every month. Here, T increase by the fixed number. Okay, that is month is increased and the height h decreased by the fixed number. Okay, month is increasing, the height is decreasing. Therefore, this is an example of linear decay. Okay, here one is increasing with a fixed number, another one is decreasing with a fixed number. These type of situations comes under linear decay. Correct? So linear growth means it's increase with the same amount. So linear decay means it's decreased by the same amount. Okay, I think you can understand the difference between linear growth and linear decay. Right, so based on this, right, we will be just moving on to the exercise. Exercise 2.4. Suppose a plan has height 1.75 feet and it grows by 0.5 feet each month. Find the height after 7 months. Okay, find the height after 7 months they are asking. Okay, I have given sample image. The plan height is 1.5 meter, sorry, 1.5 feet, and it grows 0.5 feet every month. Okay, so now we have to find the height after 7 months. Okay, answer first we'll just write what is given in the question. Okay, given initial height is 1.75 meter. Okay, 1.75 feet. Okay, so growth per month is given 0.5 feet. Every month is increasing 0.5 feet. Now for the first question, find the height after 7 months. Okay, height growth in each month is given as 0.5 feet is given each month. So now we have to find height after 7 months. Okay, height after 7 months. So we can just write it as height as I am just taking as height is equal to h. Okay, so in the beginning it is 1.75. Okay, 1.75 is a fixed. Okay, plus so every month is increasing 0.5. Okay, 0.5. If it's a 1 month, so we'll be just adding these two. If it's 2 month, okay, so it will be increasing 3 month, 4 month. Here they are asking for 7 month. Okay, so into 7. Okay, into 7. Correct. So height is equal to 1.75. Okay, initial stage, and plus 0.5 feet is increasing every month. So we have to find out for 7 months. Okay, how we have formed the how we have framed the linear pattern, the same concept we are just proceeding it. So now I can just simplify it. Okay, 1.75 plus 0.5 into 7, that is 7 5s are 35. So before one place you have to keep the decimal points, so it will become 3.5. 1.75 plus 3.5, so you can just add. Okay, so it will become 5 5.25 feet. 5.25 feet. So this is how we have to find the answer. Okay, this is only first part is over. So the next one, second part, make a table of values for t varying from 0 to 10 month and show how the height increase every month. So we have to form a table. Okay, how the t is varying from 0 to 10 month. Okay, one is month column, another one is height column. Okay, so I have taken the tabular column, right? So you can just refer it. So now t month. Okay, month is denoted by t. If it's the first month, okay, that is 0 month. Okay, initial stage, we have the height of, what is the height of the plant, right? Yeah, plant. So the height of the plant, okay, in 0 month, that means in the initial month, the height of the plant is given 1.75. So after 1 month, okay, so every month is increasing by 0.5 feet. Therefore, after 1 month, so it will become 2.25. That means how we are getting this. So with this, so we have to just, so with this, I have to add 0.5. Okay, just add 0.5. 1.75 plus 0.5. So you will be getting us 2.25. Next, after 2 months means, so here again, so it's increasing by 0.5. Okay, 0.5 is increasing. So every month is increasing by 0.5, 0.5, 0.5. So just add 0.5 so you can able to fill the tabular column. Okay, now they are asking us to do it from 0 to 10 month. Okay, 0 to 10 month, right? So one by one, if you are adding it, so you'll be getting the height for every month. So third one, find the expression that relates h and t and explain why it's represent the linear growth. So we have to relate h and t, right? So I'm going to write the expression. Okay, let the height after 3 month. Okay, height after t month. I'm just taking as height. Okay, height after t month is h. I'm just taking as h. Now I have to form a linear pattern. Okay, linear pattern or linear expression. So how can I write h? Okay, h is equal to 1.75 is fixed. 1.75 is fixed. Okay, plus 0.5 every month is increasing by 0.5 into t. Okay, t is nothing but month. T is nothing but month. Right, so this is how you can just form the linear expression. If t increase, the height also keep on increasing. If t is 1 month, okay, so we have to take t is equal to 1. If it's 2 month, t is equal to 2. 3 month, take 3 is equal t is equal to 3. So we will be getting the height according to that. Now this represents linear growth because height increased by a constant amount 0.5 month. Okay, it's keep on increasing, right? The constant amount 0.5 feet. Okay, every month. Therefore, this is comes under a linear growth. So as we discuss the definition for linear growth means, okay, what is linear growth? Okay, so it grows continuously with a constant, okay, same amount. Okay, here is increasing by the same amount 0.5, 0.5. Therefore, this is comes under linear growth. Question number 2. A mobile phone is bought for rupees 10,000. Its value decreased by 800 every year. Find the value of the phone after 3 years. Okay, so initially the phone bought for rupees 10,000, the value is decreased by 800 rupees every year. So we have to find the value of the phone after 3 years. Okay, so initial value is given rupees 10,000. Okay, initially is given rupees 10,000 rupees. Though decrease per month, so that is rupees 800 is decreasing every month, right? So decrease in value after 1 year. Okay, every year is decreasing by so rupees, okay, 800. Now, so the value after 3 years. Okay, after 3 years we have to we can just easily find out the value after 3 years, right? Either we can just denote it by v. I'm just taking as value is v is equal to 10,000 is fixed. Okay, 10,000 is fixed. Okay, so depreciate decrease means so you have to subtract. Okay, minus. Okay, 800 is decreasing every year. Now we have to find out for 3 years. Okay, find out for 3 years. So into 3. Okay, into 3. So we'll be getting the answer. Okay, 10,000. 10,000 minus. So 3 8s are 24. Okay, 2,400. So 10,000 minus 2,400, you will be getting 7,600. Okay, 7,600. Therefore, the value of the phone after 3 years is equal to rupees 7,600. Okay, rupees 7,600. Hope you can understand. So linear, this is comes under linear decay. Okay, every month 800 rupees is keep on decreasing. So next, so make a table of, okay, make a table for t varying from 0 to 8 years and show how the value of the phone we depreciated with time. So depreciated is nothing but decreased. Okay, here also we have to form a tabular column, right? So I have just taken the tabular column, right? We'll understand. So years, okay, in the beginning, okay, initially 0 years, okay, till 8 years I have taken. So in the beginning, okay, initially the cost of the mobile is 10,000 rupees. Okay, after 1 year is decreasing. After every month is decreasing by 800 rupees. Therefore, after 1 month, so it will become 9,200. That means how we are getting this means, right? So here we are just subtracting 800. Okay, 800 is subtracted, decreasing. 10,000 minus 800 is 9,200. Again, so we are just subtracting for the second month. If it's second month, third month, fourth month, right? So instead of, right, the month is keep on, okay, here the time period, okay, time period is increasing it. The same wise, the amount of the mobile phone is decreasing. Therefore, this is comes under linear decay. So we have to find third question. Find the expression. Okay, find the expression that relates V and T and explain why it's represent linear decay. So I'm going to write the linear expression. Okay, so V is nothing but value, okay, in terms of T, time. So let value after T years. I'm just taking as that is V value. So I have to form a linear expression. V is equal to, here initially it was 10,000. So 10,000. So minus, okay, every month is increasing 800 rupees. Okay, next into the time T, okay, 800 T. Okay. So now this is the linear expression. So this represents linear decay because the value decreased by a constant amount, rupees 800. Okay, rupees 800 every year. Therefore, this is called as a linear decay. Question number 3. So the initial population of the village is 750. Every year, 50 people move from a nearby city to the village. Find the population of the village after 6 years. So we have to find the population of the village after 6 years, right? So in the question they are asking, so the population of the village after 6 years. So we can just write, so or you can just write what is given, then you can go with the answer like a previous question. So here I just taking directly, I'm just writing the answer. Okay, population of the village after 6 years. Okay, this is the first one. So population of the village. So after 6 years, okay, after 6 years, okay, population I'm just taking as P, okay. So P is equal to, so the population of the village after 6 years they are asking, right? So I'm just taking as P. P is equal to initial population of the village is 750 is given, okay, 750. Every year, right, 50 peoples are added to the village. So it's addition. Okay, 750 plus, okay, 50 peoples are added every year. So 50 into, they are asking for 6 years. Okay, 6 years, so 50 into 6. So 750 plus 5 6 are 30, 300. Okay, 750 plus 300 is you are getting 1050. Okay, after 6 years, right, 1050 peoples are in the village. So now second one, make a table of value for T varying from 0 to 10 years and show how the population P increase every year. Okay, here the tabular column is about T years. Okay, T representing years and P representing population. If it's a 0 year, that is initially 750 people in the village. After 1 year, right, 50 peoples are added. Okay, 50 peoples are added. So just add 50. So you get 750 plus 50 is 800. The next year again, right, so 50 is added. So every year 50 peoples are increasing in the village. So they ask us to take from 0 to 10 years. Okay, in the 10th year, right? So the population will be 1250. Now find the expression that relates P and T and explain why it's linear growth. Okay, we are going to write the expression. Let population after T years is P. I am just taking P is the population. So I have to form the linear expression. P is equal to 750. Okay, 750 is the fixed plus 50 people are increasing 50 into T. Okay, 50 into T, 50T. So this represents linear growth because the population increase by a constant number 50 every year. Okay, so every year 50 people are increasing constantly. Therefore, this is a linear growth. Okay, hope you can understand. Right. So now we're just moving on to the next question. A telecom company charge rupees 600 for the certain recharge scheme. This prepaid balance is reduced by rupees 15 each day after the recharge. Okay. So initially it charges rupees 600. So every day, okay. So every day it's deducted or reduced 15 rupees after the recharge. So write an equation that models the remaining balance P of X after using the scheme for X days. So explain why it's represent linear decay. So here you have to write an expression that, so the expression is let remaining balance after X days. So we have to take it as P of X. P of X is given in the question, right? So we have to take it as P of X. If it's not given anything, right? So balance mean we'll be taking P. Okay, P of X. So we have to form a linear expression we have to form. Okay. Okay, P of X is equal to, here the fixed amount is 600 initial amount, right? So it's a linear decay. So minus every day 15 rupees reduced. So 15 into, so what do you have to use? X. 15 into X. 15X. So this represents linear decay because the balance decreased by a constant amount rupees 15 every day. Okay. Next, second question. After how many days will the balance run out? That means it will become 0. After how many days the balance will become a 0. So when the balance run out, that means P of X is equal to 0. Okay, P of X, you have to take it as 0. We have to find out after how many days. Okay, right? How to find out in the place of P of X, you can just take it as 0. So if it's 0 means you will be writing this as, okay, 0 is equal to 600 minus 15x. So linear equation. Okay, this we can just write in a simple way. So change the place, right? So you'll be getting us, right, or just take 600 to this side. Okay, next step I'm just writing down. So bring the 600 to this side. Okay, 0 minus 600. 0 minus 600 will come is equal to minus 15x. Okay. So next step, 0 minus 600 is, okay, minus 600. Minus 600 is equal to minus 15x. Now you just take this minus 15 to this side. This is the multiplication with x. Multiplication come this side, it will become division, right? So minus 600. So divided by minus 15. So minus minus get cancelled, right? 600 divided by 50. So you'll be getting the answer. Okay, 600 divided by 15 is 40. So 40 is equal to x. So the balance will run out after 40 days. Okay, after 40 days. So make a table for values for x varying from 1 to 10 days and show how the balance reduce with time. Okay, so here also we have to form a tabular column. Okay, so now I'll be just showing the tabular column. Okay, days. Okay, here they are asking the answer from, okay, day 1, 2, 3, 4, not from 0, right? So they're asking directly from, okay, after 1 days, after 2 days, 3 days. After 1 days means 585. Now here every day the amount is, okay, deducted. Okay, amount is decreased by rupees 15. So we have to minus 15. Okay, minus 15. Okay, so every time we just minus 15, so we'll be getting the answer minus 15. Okay, tabular column. Okay, so this is the concept. Okay, so here today's class we just learn about what is linear growth and linear decay. So based on that we have completed the exercise.